What's up, guys? You are on A-Level Mechanics Revision with Daniel Dallas. Here's force and motions. So that's the subtopic of the mechanics for A-Level AS Year 1, and we're considering motion in 2 dimensions. Make sure you watch the previous video dedicated to motion in 2 dimensions. And here we're also going to consider pretty hard and nice problem. So grab your pens, grab your notes, let's get started. But before, just a quick reminder, so you are always welcome to share in the comments the topics that you would like to see dedicated to GCC, A-Level, maybe and other stuff. So please share in the comments. I actually appreciate every single subscriber and visitor on my channel. So guys, you're all more than welcome. Let's get started. So here is an object A with a mass of 500 grams is moving in the field of 2 forces, F1, 2i minus 5j, and F2, okay? So at time instance t0, the velocity of object A is VA, given as a vector, and another object B is moving with constant velocity, VB, with no force applied to it. With the time when 2 objects be moving in the same direction, you need to find that time. Okay, so as normally I do, I just highlight the phrases that actually we are interested in. So I'm going to highlight several phrases. The first one, 500 grams. Make sure you remember that units, normal units for SI system, as you remember, SI system, is actually kg, kilograms. So in this case, just normally use that to highlight. Okay, so 500 grams. Normal units are kilograms. So that's why definitely we need to convert. Next, it's moving in the field of 2 forces F1 and F2. So hold on. We need to understand that if the total resultant force is not zero, is not balanced, according to the second Newton's law, it will have acceleration. Okay, so that's why I highlighted that. And this is the first that we're going to discuss. So let's do it right now. And just remember that we have the second Newton's law, F resultant force will be equal to ma, because it causes acceleration. No resultant force, no acceleration means the body keeps moving. If it was moving with a constant velocity, if the velocity is 0, just keep at rest. All right, so just remember, in case when we have 2 vectors, F1 and F2, and F2, we simply arrange head to tail rule. So make sure you remember this. So this is F1 and this is F2, and the resultant force simply is going to be a resultant vector. But however, we are not going to add in this way because we're given components, and it's much easier to do through components and not even to draw. So F1 plus F2 is going to be the resultant force that acts on the object A. So that's why I mark a resultant force as Fa. It will be equal to the sum of 2 vectors. And simply what we're going to do, we just add components. So component I is 2, component I here is 1. So that's going to be 3i. And the same manner we do minus 5 plus 3 for j component, we'll get minus 2j in newtons. Okay, so next part. As a result, we will have acceleration. So anyway, we need to know acceleration for the object A. So acceleration is simply, just by rearrangement, we'll get F over the mass. So in our case, acceleration for the object A will simply be, so mass in our case, we need to convert into SI units. So 0.5 kg in this case, 0.5 kilograms, and we can divide simply components by 0.5. But because we divided by 1/2, we just flip it over, and that's why we'll have the following components: 6i and negative 2 times 2 for j. Now, units of acceleration, so meter per second squared. Okay, I always keep track of units because that's how you understand what actually you're doing. So it's not necessarily probably for mechanics level, but for those who also pass in physics, it's a very good skill. So for engineering, specialization is pretty good. And please, guys, you need to always keep track of units. It will save your life one day on an exam. Trust me. Okay, let's go next. We have acceleration and not equal to 0. So that's why the velocity for vector VA over as a function of time, let's say VA as a function of time, according to the formula, just remember it's linear dependency from acceleration, from time with constant acceleration. So acceleration is constant, and that's why we'll have the following form. So it's VA from 0 plus acceleration of a particle A times time. All right, so just make sure you remember this. You might remember it from physics, and I encourage you to memorize that. U plus AT, where U is the initial velocity, so this is the vector equation, or you can break down by components if you like. Okay, so in our case, initial velocity of object A is VA, and hence we can arrange the function, vector function from time, simply by adding I plus 3j to A, acceleration, which is 6I minus 4j times time. All right, so that's VA. Of course, you can combine components. I just highlight instead of combining them. So I components and let's say j components. If you like, you can combine them and write like as 7I, and here is going to be 3. But I'll do later. So right now, let's get straight to the point. What we're going to have, we need to find, about another object. Object B is moving with a constant velocity with no forces applied. So that means we just simply can say that VB from time is not changing. So it doesn't depend on time because it's constant. And it's always equal to 2I minus j. So everywhere meter per seconds. Okay, what we're gonna do right now, we need to find the time when two objects will be moving in the same direction. So, for example, if VA is the velocity for the first object A, let's set up like this, and let's set up another vector for velocity VB. The same direction means they moves probably on parallel lines, yes, at that time, not probably the parallel lines, but at this point of time, velocities are directly the same. So here is VA and here is VB. So what it means in terms of vectors, they're collinear, right? So that's why you can say that VA vector times constant k, right? VA times constant k, so probably better to times B vector. So that's why, let's say VB, vector VB, which is constant, is going to be collinear, basically directly proportional to the vector VA. So that's why instead of writing k times VA, because you see the expression is quite bigger, so we can times k by the vector VB, because smaller components, smaller numbers, it's much more convenient. So it doesn't matter where you put k as a factor. So we set up like this. So this is going to be it works pretty bad. Okay, anyway, so we set up VA and they're collinear. They're parallel and directed in the same way. Okay, so VB and VA. Let's split or let's break up into component form. So you remember that component form is simply column vector we use the matrix form or matrix notation. So that means, for example, VB we can write as 2 and -1 instead of writing I and J. So that means we multiply by K, we need to multiply every single component. So that's why it works like K times VB. It works like each component is multiplied by K. Okay, and that is going to be equal to, and now it's time to combine the terms or components. I plus 6i is going to be 7i, so it's 7. And the bottom components for j, it's 3 minus, oops, my bad, sorry. We need to expand time, and time goes everywhere, so as a factor. So that's why we'll have 1 plus 6t, 1 plus 6t. And here is going to be the same, 3 minus 4t. So 3 minus 4t. And this is their basically matrix equation. How to write it normally? We just simply need to say that, okay, we've got this. So I just for a while be concentrated on that equation. And here we just want to write each component, so the top components basically I and the j components, as two equations that are actually simultaneous. Let's write this. So we have 2k will be equal to 1 plus 6t, and the same is fair for the j components, which is -k equals to 3 minus 4t. So we're looking for time, and that means we can kill k value here. So we multiply by 2, and now we can say that we subtracting. So we using elimination methods. No, we add them because opposite signs. So k component, the k will be cancelled, and here we'll have 1 plus 6t and 2 times, so we add in, so that it's going to be plus 6 and -8t, okay, because we multiply by 2. So that's the final equation from where we can pick up time. So here actually I need to write solve for t. Okay, so solve, and by solving that, 6t minus 8t is -2t. So 2t will be equal to 7, from where time is going to be 7 over 2, or 3.5 time seconds. Alright, so that's the final answer, and this is the time when two objects will be moving at the same time. One more time, what it means. This is the key or core equations. This is the core equation that we set up here. It means that two vectors of velocities for objects will be collinear. So collinear, okay? And final result time is 3.5 seconds. Okay, so that's the solution. Hope you like that. Hope you get it. If not, so ask any question. You are always welcome. If you need something similar, I can also explain. Also, actually have a bit easier level. This was hard level, I consider, at least. So make sure you understand, and please subscribe if you're new here. Don't forget to smash the bell button. You all guys are very welcome. So ask any question you like, give the comments, and you'll see more interesting stuff here. Peace.